The notes of the eccentric connections and the types of eccentric connections have been posted in the classroom. Please go through before we solve this problem. So this is a problem based on type 1, that is when the eccentric load is in the plane of group of the bolts. We are given a problem in which there is a ISMC section. If I have to see this in the plan, it will look something like this. Okay, so this is a C section to which a bracket in the form of a plate is connected. So this is the top view. And this here out to out is 300 mm. We've been given M20 bolts of 4.6 grade, so we know that the nominal dia is 20 mm, the diameter of the hole is 22 mm, ultimate strength of bolt is 400 Newton per mm square. The ISMC that we are using is a rolled steel section, and therefore the ultimate strength is 410 Newton per mm square. The thickness of the web, this you will have to check in the steel table, is 7.6 for ISMC 300. Now let me explain to you what is the web and what is the flange. So we have a C section here. These two are called as flanges, and this is the web. In your steel table, you will see this is given as TF, whereas the thickness of the web is denoted by TW. If we have an I section, again this is a flange, this is also a flange, this is a web, thickness of this is given by TF, thickness of this is given by TW. So continuing with the problem, now we know that this is a lap joint between the C section and the plate. Okay, that means they are overlapping each other. Therefore, the bolts are in single shear. Therefore, the design strength of bolts in shear, I am calculating the design strength directly and not the nominal strength. That is why I have divided by the partial safety factor of 1.25. This is 45272 Newton. Next, I need to calculate the strength in bearing we know that KB is the least of these values. So this entire length here is 300. So half the width is 150. We need to find out the edge distance. So the edge distance would be 150 minus 60. This is the edge distance E. Substituting all this, the pitch as given in the diagram is 80. This is the governing value of KB. It works out to be the least of all, and it is 0.96, 0.96212. So the design strength in bearing substituting the values, this is greater than the design strength in shear. Therefore, the design strength of a bolt should be lesser, the minimum of the two, and it is 45272. So shear is the governing criteria. Next, we calculate the force in extreme bolt. That is a bolt which is the most at the most distance from the force. In notes, we have seen that the direct shear force is given by P upon N, where N is the number of bolts. In our case, it is 5, that is why 5 in the denominator. Now, the center of gravity of bolted connection is at the center of central bolt. What this means is we have 5 bolts like this. This is the line of CG of the connection, and it is passing through the center of this central bolt. We need to find out the distance R. Now what R is from the center of the CG to the center of the bolt. Okay, so it will be equal for 4 bolts. So for 4 bolts, R equals to 80 square plus 60 square, which is 100 mm, and for the central bolt, R will be 0. Therefore, force due to bending moment in extreme bolt is given by the formula. Substituting all these values, the angle between the two forces is given by theta, where cos of theta is 60 upon 100, which is 0.6. So the total shear force on extreme bolt on solving this, you will get 0.67199 times P. Equating this to the strength of bolt, the strength of bolt was 45272. We get the value of P as 59413 Newton, or 59.413 kilonewton. So in the diagram, if we see, it was mentioned that load per bracket plate. Okay, so there are two bracket plates, as in, if this is your C section here, so probably there is one here on this side and one on this side, and P is the force only on one bracket plate. So if we need to find out the total load, factored load, on the bracket, it would be 2 times the value that we have just got. So it would be 118.426 kilonewton. This would be your answer if there is only a single bracket plate. Okay, but from the diagram it looks like there are two bracket plates which are attached, because it says load per bracket plate, so that is why we multiplied by 2. If this is not mentioned whether the P is per bracket plate, then you stop at this. So this would be your answer. Thank you.